Yep.
Did you see last time how there was a little bit of a dark, there was a blackout at the beginning? Did you see that?
I didn't actually watch it, so I'm not sure.
I did because you made a comment on it, Holly, and it was just because, do you remember she changed, she closed out, she started
Oh.
and then we all jumped over there.
Okay, because I didn't know what that was. But...
Yeah.
Your turn's next.
Figuring it out.
Your turn's next, Holly Joe.
I know, and that's why I'm kind of sad because my internet's even getting worse now. I was worried about our connection. I should at least try it, and then if we do have a super bad connection, we'll have to try someone else. But
That's a good idea.
If you need to jump in and start doing it, we understand if you want to do it next week or whatever.
Yeah, I'll do it next week.
Okay.
So
On Wednesday, by the way, Wednesday is going to be different for me. It's our stake is having a day of consecration at the temple. So they're inviting us to spend the entire day at the temple, and I'm going to try to go for much of it. Nice. And I'm going to try something, but I'm probably just going to get dressed and step out to meet you for the meeting in my car and take a break for a couple of hours, or maybe go get some lunch with my husband. But I don't have Wi-Fi, so I'm going to try it on data with my phone and then use that as a hotspot on a little iPad or something.
Yeah.
Okay.
Other than that, I can do it on my phone, but it's going to be hard to take a test on my little phone.
Yeah.
Right. Oh, wait. We don't have a test on. Do we have a test next week on Wednesdays?
Well, yeah, we do a test together.
We always do each meeting. Yeah. All right. So anyhow, I'll figure that one out. Just so heads up.
So that's this Wednesday, right?
Yeah, in 2 days.
Okay. Sounds like a plan. All right. Do we need to go over the individual preparation assignment? Anyone? Do we want to go right to the quiz?
I think it's okay. Hold on. I need to go again.
Did anyone know if we were going to miss Emily today?
I didn't hear anything.
It's Emily, right?
Right, Emily Galbraith, yeah.
And I haven't heard. Oh, wait a minute. I'm looking at the email. It says my computer's having troubles today. I should be up and running in a few minutes. That was 9 minutes ago.
Oh,
Okay.
good.
So she's hoping to join us.
Okay. Because she's always got good answers. I really like to bounce our questions off onto her. I don't know if it's like the young brain or what, but,
But explains things well.
Yeah, seems like she understands what's going on here.
Mm-hmm. Most of the time I understand, but I can't explain it.
Yeah, she's good.
The words inside my head do not come out.
You do good. Everyone together does good.
We learn from each other. That's good. Yeah. Okay, I'm starting the quiz.
Looks like we need a normal probability applet up, possibly.
Probably. That's usual.
So question 3 is find the margin of error for a 90% confidence interval when the standard deviation is 50 and the n is 25. So
I just got a message from Emily.
What are we going to do? That 1.64 times the standard deviation, which is 50 divided by 25 square root.
Okay, hold on. Holly, go back and teach me.
So I wrote down the numbers that equate to the percent, 90% confidence is a Z. I don't know what the Z asterisk thing means, but they're calling it Z.
Yeah, it's the critical value.
Okay. How do they say that? The correct value?
They call it Z star. It's the isn't that the
critical value? Okay, critical value. So it's 1.645.
Yes.
And we're going to do that times 50 divided by the square root of 25. That should be our answer.
I just was getting the text too. I'm sorry, I was a little distracted.
Yeah.
Okay, so for the 90, we have the 0.9 we have.
So sorry, what are you trying to find?
It says find the margin of error.
So we have m equals that critical value times
It's times
the 50.
sigma over the square root of n.
Mm-hmm.
Okay. Well, that's easy because 25 you can take the square root easy and
Times 50 divided by, so,
5.
yeah, divided by 5. So that's 10.
Uh-huh. So is it 16.45?
That's what I'm getting.
That's what I got.
Those were easy figures to work with. That's nice.
It was nice.
And did you guys see something about how you always round up? And I don't know if that has to do with this margin of error or what, but
It's
like
when we find the n.
the n. Okay. Because
Yeah.
I couldn't remember what part that was, but I thought that's something new and scary.
Yeah, because you're talking about a number of people you need to talk to.
Oh, you can't have like a half a human.
Yeah.
So it
0.45 or
So I'll say that again.
it depends on the unit. Is that what they're saying?
Yeah, so it sounds like n because it's a sample, it's an actual physical thing. It can't be like a half of a thing.
yeah.
It can't be. So it's always going to round up.
Right.
Okay, that helps.
Yeah, I'll do the grammar hammer on this. Which of the following statements is, oh my gosh.
Wow.
Which of the statements?
I can do much better in English.
Maybe we should all just read it to ourselves. Ah. I'm still not getting it.
Uh-oh, did we lose Sarah?
No, I'm here.
Oh,
She's just thinking.
I'm reading the textbook.
I think it's number 2. But I don't know really if the other one's, if sigma squared is the interval estimate of the x bar. I don't think it is.
Yeah, I kind of don't think anything with sigma in it works. You know, A or D, but I'm not sure.
I don't know if mu is the point estimator of x bar is the correct way of saying it, or if x bar is the point estimator of mu.
I think it's number 2.
That's what I thought too.
That is a point estimator.
Yeah, let's go with that. You guys, that sounds good. I could only narrow it down.
All right, I'll read. Gina. Oh, we have this for 6 questions. All right.
So we better write these numbers down.
Write these numbers down. All right, so Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample, n equals 64, and computes x bar, the random sample, is 526. Use this information for the next 6 questions. What is the point estimate for the true GMAT score?
Five, 2, 6.
526?
Yeah, because that's your sample mean. And remember, the x bar and the mu are the same. They're the point estimate.
Okay, yeah, right.
I think that's good because the sample size is big enough.
Yeah.
And if the sample size weren't that big, we just have to compute it.
No. So this question is what's the point estimate? So basically it's saying what's the mean, point estimate and mean. Think about them as the same thing for 5. Are you on to 6 or something?
Nope.
No.
Okay.
But if the sample size wasn't big enough and we didn't know it was normal, we probably wouldn't be able to figure it out. Probably wouldn't be enough information.
Okay.
Wait, are you guys getting multiple choices on that? Because I just get an
Yeah,
answer
I was just
about
hypothesizing. No, let's go on. Yeah.
because
No,
that was
yeah,
confusing.
we were just deciding that it's because it's a normal chart, we can do that.
Oh, okay.
So that's why we can.
Okay, now the margin of error for 95% confidence interval.
Okay, so this is the interval. We want the one number to another.
So 95 is 1.96.
Yeah.
95 is 1.96.
So are you guys doing 526 minus 1.96
Yeah,
times?
plus or minus.
Yeah, plus or minus.
No, I'm not doing that because right now we're just getting the margin of error. We're not looking for the confidence interval. We're not.
That's right.
That's the
So-
next one. You were right. That's the next question.
We're really just doing 1.96 times
Sigma divided.
113 divided by 64 squared root.
All right. Boy, you are on your game, Holly.
Yeah.
Thank you. You know what? I prayed today, and I know that the Lord helps me because otherwise I don't get it.
So that's divided by 8, 113 divided by 8.
Mm-hmm.
Well, you're definitely getting it today.
I'm getting some help. But I do put my numbers in wrong on my calculator, so I kind of need to hear if you guys get the same thing I get. Because that's why I got everything wrong on my test, because I just put it in wrong.
27.69.
685.
Actually, it's for 3, so 685, right?
Yeah, 685.
Good catch on that. Making sure we're getting the right answer. We're solving for the thing that they are asking.
Yes, thank you. Yes.
I bet I'll ask the next one for the next one, because here it is. What's the lower limit?
Here is the lower limit. Okay.
Did you guys see what I put?
Go ahead.
Sorry. Did you guys see what I put on the thing? I'm able to see all of my question now. I was able to get the print smaller. Did you?
Oh
see
yeah, because you zoomed in, you zoomed out.
Yeah. Were you able to do that?
Yeah, that was a good call.
Like that helps me a ton. Okay, sorry to interrupt.
I'll look at that after the quiz. I'd like to see what you did.
Yeah. It helps.
All right, so I have for the lower limit 498.315.
Hold on, I'm not there yet.
Yeah, I'm still getting there.
I just kept that number 27.685 and
minus.
added and subtracted it.
Good job. That's it.
Exactly.
Is that right?
So basically 526 minus 27.68. 685. What did you get?
498.315.
Yeah. And round 3 decimal, so we'll keep it all.
Keep it all. On the upper limit.
Lower limit.
The upper limit 553.685.
658?
27
Oh, I put it in wrong.
plus.
Thank you. 85.
Your answer is 553,685.
Yes.
685. Okay.
Yeah, that's a 0.685.
What would happen? Oh, this is where I do get confused a little bit. What would happen to the width of the confidence interval if Gina increased the sample size? And they said this a lot in the video, but I wasn't wrapping my head around it. I knew I should have. Darn it.
It would decrease. No.
State your answer and the why. Let's work it out in our head. What would happen if the width of the confidence level increased? Wait,
The confidence,
increased the sample size.
So the sample size gets bigger.
The width of confidence, you become more confident,
the
right?
sample size.
Say that again.
And the confidence interval decreases with the sample size, right?
I actually, that's so funny. Before we started,
I think increase.
I have a note from the textbook. Actually, I think it might have been from a video. And I have a question mark by the side of it. It says, if the width of the confidence interval increases, the level of confidence increases.
That's what I thought too. Well, but how about the sample size? Because now the sample size is increased, then does the confidence width increase? That's the question here.
Right.
I'm looking up in our book real quick.
It should decrease from the central limit theorem, right?
That's what I'm thinking.
I think we should try to find this answer in our book, because there's definitely two different specifics, and one has to do with the sample size and the other one has to do with what you just mentioned, Sarah.
Four 4.2.
You think you're at 4.2? Let's see. What would happen if the confidence interval of the sample size was increased, but the other values stayed the same? If n increased, this fraction would decrease, which would lead to a smaller margin of error. In other words, the sample size is increased, the width of confidence interval decreases. You're right. So the sample size, when it increases, the confidence interval decreases. Good job. You were right.
Awesome.
So number 9 is a decrease.
I think. I'm not sure.
Is that what you read it again? Interpret it.
Where are you reading, Holly? Where'd you find that?
Where you at? 4.2, and then I just
4.2.
opened up on 4.2, question 6 on the answer the following questions.
Okay.
Show the solution.
Yeah.
That's where I read it. Oh, and then the next question is probably going to be that next question. Let's see. What would happen to the width of the confidence interval if Gina changed it to 99% confidence interval? These are the two questions right here. So if you change the confidence level, then this would lead to a wider confidence interval.
It would increase it.
It would increase it,
Mm-hmm.
I think. I get those two mixed up. Those are very difficult questions. I'm going to write those down on my cheat sheets.
You know what I'm thinking with that one?
Wow.
It's almost like, the odds and the statistics. If you're going to have more to pick from, chances are you're going to, your odds are going to go up that you're going to get something covered.
Okay.
As it gets,
so whenever you have a wider confidence interval, that makes your chances better?
You have a better chance at getting something, right?
That makes sense. How do you describe number 9? How would you say that?
The same way.
Well, the width of the confidential increase, the sample size increase, the sample size decreases. What would happen to the width of the interval if Gina increased the sample size?
That one's, I think, with the central limit.
Did we get that one right then? Because that looks the opposite.
Yeah, we got that one right.
We did? See, to me, that doesn't make sense intuitively. I definitely can't wrap my head around that one.
Yeah, it's not too, I have to really think.
Okay, so are we ready for 11?
Like she read, though, it says there, if the sample size is increased, the width of a confidence interval will decrease. It will become narrower. Okay. All right, so
even though that doesn't make sense in my brain.
that's a hard one.
But what you said on the other one did make sense. Is that first one's a little bit more difficult.
Yeah, they're all different. Are we on number 11?
Yeah.
Yeah.
Okay, more data.
Wait, what the last? Remember, it said the last 6. So is this the same information? I think, or no? Is this different? Is this new?
Yeah, this is a new one.
We did 6 already.
I think you've already done 6.
I'm gonna go
Mm-hmm.
back and look.
Yeah, I can't believe that was 6, but maybe it was.
Yeah, because I don't even know where that said that.
Okay, you guys ready?
Okay. Yeah.
Bright bulb light bulb companies planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400. And they want a 95% confidence interval with a margin of error of 50 hours. Here we go. We're going to use the M.
Mm-hmm.
Okay. All right, here we go. We only have one question on this. Okay, so what sample size do they need?
Mm-hmm. So we're solving for N.
We are solving for N, and so the solution
I
is
didn't write down. I didn't write down that.
is
What's
N.
that formula?
The formula is N equals parentheses Z star, which is what's a Z star?
That's
The
1.96 for.
That's right, 1.96 times sigma, which is 400,
100.
divided by square root of 450. What is it, 50?
because that's the margin of error.
That's the margin of error.
Okay.
Yeah.
And that's how we solve for N.
I have those little formulas on my little 3x5s.
Yeah, I didn't write that one down. Unfortunately, I'd written the
Because
other one.
they have the other one where they already have it where you have M isolated. These are just the two.
Well, and is this the one where we square it too, or no? Do we square that?
Yes, and it's going to be squared. Thank you.
Mm-hmm.
Wait, and you know what, by the way, it's not the square root of M. Take that off if it's squared. If it's going to be
Yeah.
squared, it's not the square root. Thank you, Holly. So I think
How does it look?
the formula looks like 1.96 times 400 over 50 squared.
Yeah, the whole thing squared.
Yeah.
96, because that's the 90 percentile, right?
Mm-hmm.
Or 90. What are we looking at for 95?
$95. So that's the Z star of 1.96.
Okay.
So, yeah. 26.13333 cubed. Or squared, not cubed, sorry. I get 682.951.
Okay, I got 125.44. I think I did something wrong.
Me too. I'm gonna double check.
Yeah, I'm gonna do mine over 2.
I need to find that.
Really different.
I need to see that formula with my eyes. Do you know where that's at in the reading?
Just a minute.
Yeah, let me. Oh boy, I got something different this time. It's I'll have to go back and look on.
So okay, so we're solving for M.
No.
N
Yeah.
is
For N. Okay, we're solving for N, right?
Yeah.
Okay, we're wanting to know the sample size. Okay, I found it. So it's what you said. It just looks a little.
1.96 times 400 equals. Do you have 784 divided by 50? Equals. I have a different number this time. 15 times 68.
15.68 times 15.68.
Yep. It's 245. Is that what
And
you're
then
getting?
round up. So it's 240. We always round up. It's 246.
Yeah. This one says rounded the whole nearest number for whole sample. 246.
Yeah, that's what I have. Did you get that, Holly?
245.862. Is that
And then up we round.
Up on this one
okay?
because we're solving for N. N is the thing we round up.
So we should write that down, and then N is the thing we round up. Always round up.
Mm-hmm.
Okay, cool.
And even if it's like 245.1, you're still going to go to 246.
That's going to be really tricky. I mean, hopefully I remember it just because it's so. Hopefully I remember that.
Exactly.
It goes against every other rounding rule ever, but hey.
Yeah.
Round
But
to the nearest whole number.
I liked the explanation when he was like, well, we need to talk to the bears. We're not going to talk to more than we have to.
That was funny.
And if it's like we need to talk to 12.5 bears, we better talk to 13 because 12 won't be enough.
Yeah.
You know, that kind of thing.
So the answer there is 245.
246.
Yes.
Oh, see, we talked about it. We talked about it. And I still didn't want to do it.
Do it anyway.
Okay, 246 then. Thank you for correcting me. I would have been so sad to have that wrong. Okay, we're on to the next question. 12. Oh, then 12, 13, and 14. All the rest are for
the null hypothesis and the alternative. Awesome. See if we still remember how to do this from last week. Does anybody want to read it? I read the last one, but I'm happy to.
I don't think I've read any. So I think it's my turn. Of actuaries is mu equals 100,000. And the standard deviation is sigma equals 36,730. We're interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it's higher or lower. You set up a hypothesis test with a level of significance of alpha equals 0.05 and H null, or that's not how I say it, H null.
That's null hypothesis, or just null, they call it, right?
Hypothesis, yeah, the null hypothesis is mu equals 100,000. The A hypothesis is mu is not equal to 100,000. You collect a random sample of n equals 36 women's salaries and find that X bar is equal to 111,000.
That's a lot of information.
Yeah. Okay. So we're finding the lower limit of the confidence interval.
And so is A our confidence level? Is that the 95%? Is that what A stands for?
No. The confidence level, oh, maybe it is.
Confidence level. Well,
I don't see any other numbers there that would be our confidence level.
When they say the lower limit of the confidence.
Yeah, I have the formula for you if you're ready.
Okay.
Yeah.
All right, it's X bar, which is 111,000. I'm going to write it at the same time, 111,000. And then we're going to do plus or minus. So, you know, whatever, you can do the minus, plus or minus Z, which is
1.96.
Yeah.
And that's because 0.05 is our A.
Thank you. 1.9 plus or minus that. So that's Z star times
36.
sigma over the square root of the sample size. Sigma being 36730 over the square root of 36, which is 6. So that's plus or minus. Did that? So my equation reads 111,000 plus or minus 1.96 times 36730 over 6. Does that sound right?
Yeah.
Okay.
And we're finding the lower limit. We're minusing on this one, right?
Yeah, plus or minus. Yeah, this one will be the minus one.
And we are supposed to round to the nearest whole number.
Okay, I have an answer. Does anybody else have an answer?
I have 99002.
2, yeah.
Yep.
99002.
Okay. And the upper limit is it the same confidence level, 95? Yeah. I have the upper one. Oh, wait, hold on. I have 122,998.
Yep.
Oh, but would we round up to 999?
No,
See,
that's only the decimals.
This isn't the one we're rounding up, is it? So
We
just
would
round. This isn't solving for n, so
Right.
we don't want to change this unless it. Okay. See,
Yeah.
it's gonna confuse me already. So then this number is 122998.
112.
I'm sorry, 122998.
Yep.
I said 12, but 122998. Is that right?
Oh gosh, sorry. Yeah.
Or 1222,998.
I think we're good.
Yeah.
And then, so just to go back real quick, are we sure then that we rounded up? Yeah, we did round that one up to the nearest whole number, right? The 99002.
Yeah.
I think we did.
Okay. I'm getting so confused. Okay. Okay, there are, number 14, there are 3 requirements that need to be checked when computing a confidence interval for a mean. Ooh, I didn't write this one down either.
I have it.
Is it all of the above?
Oh, okay. 1, 2. Yeah. That's all of the above.
Or there are 3 requirements needed to be checked when computing. I don't know if those are the right answers, but I mean, that's kind of the only answer you can take because that's the only one that gives you 3.
That's kind of nice. Once in a while they give this to us, don't they? Are we going to submit?
I will take it.
Ready.
How'd we do?
We got one wrong. Which one?
We got them right.
I got all right.
I got half on 13. What did you guys do for answer 13?
That's worth enough.
The one with the 12
Oh.
is 122,998.
Well, because it says that I got 13 out of 14 right. So what did I do wrong?
There must be
Why
something up above.
Number 12. What number did you miss? I'm sure you just put it in wrong.
I got number 6 wrong. I put 27.585.
Oh, it's 685.
What is it? 2.27?
27.685.
685. So I
Yeah.
just typed that in wrong.
I bet you
Well, I'm
did.
going to go back and get 100. That's for sure.
Oh,
Oh,
yeah.
yeah. Take every point you can.
Especially when I'm getting such terrible quiz grades. So yeah, question 6. Okay. All right.
All right,
Thank you,
thank
ladies.
you.
So when do you want me to try to do it this Wednesday, or do you want me to wait and give you another turn, Leilani, and then do it next week?
I can do it this Wednesday. It doesn't matter.
Okay, and then I'll start next week.
Okay. Sounds good.
Cool.
Hey, did you want to know how to change your print?
Yes. Would you tell me how to change that side when I read? Yes.
Yeah.
Thank you for reminding me.
So if you go to your upper right-hand corner, are there 3 dots?
Upper right hand.
Like of your browser?
Oh, those. Yes.
3 dots like on top of each other. Go to Zoom
Yep.
and change it to 100 or 90 or whatever you want.
Well, that's awesome.
That helps a ton.
Interesting.
And I don't know why it changed on me all of a sudden, because for like the first couple of weeks of the semester, I was fine. And then all of a sudden jumped up bigger. I must have pushed it or had one of my kids push it or something.
No, mine was the same way. Thank you.
Yeah.
Yeah, actually, if I went smaller, I take it down a little bit, and that's helped me see more of the graphs. So I'm at 90%. Hey, thanks, ladies. Have a wonderful day. Appreciate all you do.
Thank you. You too. Have a good one.
We'll see you.
Take care.